Good morning, guys. Ashok is here. Ashok, would you like to welcome all of us? And can I request all of you to enable your videos for a quick look? Great. That is Tanuj, our hero. Hi, Tanuj.
Hi, sir.
Okay. Sure, Ashok, you're welcome. Um, Sumant, can we see you?
Hi, are you able to see me?
Oh, yeah.
So
Oh,
that
yeah.
I'll have better lighting in my room.
Oh, yeah. No problem. All right. So Tanuj says, Sumant, I can see. Obviously, I can see myself. I saw Neha somewhere around. Where is she now? Madhav, just enable your video just for a minute or two, and then we'll vanish behind the screens. Oh, great. PR Gaming 21, the official name is? You're on mute. You're on mute.
My name is Pranav.
Pranav, excellent. Hi, Pranav. Okay, oh, that's PR for Pranav Gaming 21. All right. Okay, Madhav, can we see you, please? Neha, you too.
It doesn't work.
So that, okay, is it that you don't have a cam? Can't be the case.
It's
Yeah,
not
Mike.
letting me. It's
No,
not
it's just
letting
I'm
me
just
share my
using a
camera.
monitor.
Can you guys hear me?
Yeah.
Yeah.
Yeah. All right. Thank you.
It's not letting me share my camera.
Oh, I share screen. Yeah, you can share your screen when another person is sharing.
Okay. All right, no problem at all. Over to you, Sumant.
Hi, so my name is Raja Suman, and I'll be the trainer for the session and this course called as IoT with Python. So what we will be learning with this course is you will be gaining a programmatic experience on how to use Python and develop basic IoT projects and understand science in a better way. Because what IoT essentially is, um, connect uh, connect internet to the physical device so as to make it more smart. And physical devices in the sense, it could be your fridge, it could be your door, it could be your television set, it could be your computer. So what we actually want to do over here is learn how we can control physical things, read data out of these things, and then we'll see what else we can do with the data that we gather around. So uh, all this technical jargon you may not be able to understand at this point, but uh, as a beginning step, let us start our today's session with basics of programming. Then I will gradually introduce you to programming with Python, and then we will jump into the bandwagon of having IoT. Okay, so I'll share my screen. do let me know if you can. Uh, is everyone able to view my screen?
Yeah, we can see your
Yeah,
screen.
I can. Yeah.
Yeah. Okay. So let's get started. Um, so the first topic that we will be dealing today is computers and programming. This is a basic introductory uh, thing that we need to have before jumping into programming with Python or any programming language. So there, I will teach you a few basics that you need to understand before jumping into the coding and programming stuff. Now, I assume everyone uses computers and smartphones these days. So first, let's start with uh, uh, the basic thing. How many of you um, have experience of using a computer on a daily basis? And please share your experience on how you use a computer in your daily life.
Can I go first?
Yes.
Uh, so basically, I finished my homework and my schoolwork, and after I finish that, I play video games. So that's my daily computer use.
Oh, yes. Yesterday in our chat session, I have seen that most of you use computers for video gaming. Uh, I'm not a gamer as much as you guys, but I use computers for many other cool stuff. Okay, so uh, and anybody else on how you use your computer? So for one answer that I got is for homework and gaming.
Guess that was Yashwant, right? Yash.
Yeah, that was me.
Great. Thank you, Yash. All right, let's move forward. Who wants to go next?
Okay,
Let
so think about some different ways that people use computers. In school, students use computers for tasks such as writing papers, searching for articles, sending email, or participating in online classes as of this. Uh, but if you consider your parents, that is, who work, uh, people might use computers to analyze data, make presentations, conduct business transactions, and trivial job related stuff. Yes, so that you might have also seen your parents do some computer programming at home. And then you might have also experienced the usage of computers in grocery stores, in supermarkets, at a shopping mall, and also you might have witnessed a computer uh, in your cars, right? So computers are everywhere these days. Uh, so let's get started on this course. So computers in everyday life, we have seen that computers are being used at home, at school, at office, and where not. So now let us see what else uh, do we need to know about before jumping into the programming. So having knowledge of computer programming requires you to know two basic things. Everyone might be knowing that we do have hardware and software which forms computer programming. So now um, your kids might be knowing the basic difference of what a hardware is and what the software is. So I need any volunteers over here. This is a very basic thing. Um, can you please answer or tell me the difference between a hardware and a software?
Okay, let's pick people. Think Tanuj, superstar. Go ahead.
So the difference between hardware and software is the apps that run is the programming and apps that run in it, and hardware is something that you actually touch or feel.
Oh yes, yes, nice. And everybody might have their view or definition of hardware and software. So that's a very good thing. Uh, Anybody else wants to try?
Okay, let me pick then. Madhav.
Yeah.
So, what's your understanding of hardware and software? What's the difference?
Hardware is the components that make software, and software like the programs and things you view on the monitor or screen.
Yes, yes, correct. So the concept behind hardware and software is that the physical devices that a computer is made up of is referred to as the computer's hardware. See, um, and the programs that run on a computer are referred to as software. So physical devices form our hardware, and programs that run on the hardware um, compute the software. So, so what are the different hardware components that you people know
Like the parts of a computer.
of?
Is that what
Yes,
you're trying to say?
yes,
Oh, like a CPU and like a motherboard, that type of stuff.
yes, yes. Please go on.
Like CPU, motherboard, RAM, graphics card, storage, um,
Mhm.
case, power supply.
Yeah.
I think there's more than that. Yeah, isn't that it?
Yes, yes, yes. Correct. So a computer system uh, and the hardware of a computer system mainly consists of three major components. The first one, as all of you know, is the central processing unit. The second one is our main memory, or the RAM that you guys call it. And the second one is your hard disk. And you have other trivial components like the input and output components like a monitor, a keyboard, a mouse, a webcam, a printer, or a speaker, etc. But please note that the secondary components, that whatever I have discussed, that is the mouse, keypad, or the monitor, you need not have these components physically present for you to call it a computer. How many of you agree with me with this statement?
Yeah, I agree.
You agree? Yes. Okay. Anybody else?
Yeah, I agree with you too.
Great.
I agree with it too.
Nice. Nice.
I
So,
agree.
so here, um, you did not have uh, a keyboard or a mouse or a monitor attached to the central processing unit in order for you to call it a computer. So, in order to call a computer, you just have to have three basic components: the central processing unit, your RAM, and your hard disk. This will do. Okay. So now let's move on to discuss the central processing unit in much more detail, and let's see what you guys are using. So may I know what is the CPU that you people have? See, even a laptop does have a CPU in it.
I have a i7 7700 HQ.
Oh, okay. So i7, it's manufactured by Intel.
Intel, yeah.
Yep. And anybody else apart from? I'm sorry. Is that Tanuj?
Yes, Shwan.
Yep. Okay.
Intel,
Okay.
yeah.
So anybody else who uses other than Intel processors? Okay, so I do not have a response here, but let me just tell you that Intel is a major manufacturer of CPU, but apart from Intel, there are other companies who manufacture CPU for us. Okay, so ARM is one,
AMD.
and you have CPU of uh, many other manufacturers, but popular ones, or the ones who enjoy the lion's share in the market, are your Intel and AMD, followed by ARM. Okay, so I am introducing you a new uh, CPU over here, that is called as ARM, because in the later part of a course, I'll be introducing you to a single board computer, that is Raspberry Pi, and the CPU inside Raspberry Pi is called as ARM. Okay, so it doesn't use your regular Intel processor over there. It uses a special type of CPU called as ARM. Fine. Then the second hardware component that we would like to discuss is the main memory, or the RAM. Okay, so here we can see that there are different capacities of RAM used by different individuals, uh, and the amount of RAM that you choose over will decide how fast your program can get executed. Okay, and then we have secondary storage devices, also called as your hard disks. Okay, main memory or the primary memory is called as the RAM. The secondary storage devices are the hard disk. So you have hard disks of 1 TB, 2 TB, uh, and you can gradually increase the storage size depending on the budget that you can invest on your computer. Okay, so we have briefly discussed the parts of the hardware, and we have seen that the hardware, it primarily consists of the CPU, the main memory or the RAM, and the secondary memory or the storage devices, also called as the hard disk. So if you have these three components, you can call it a computer. You need not have uh, a keyboard attached to it. You need not have a mouse. You need not have a printer. You need not have a webcam, or you need not have a speaker set in order for you to call it a computer. Okay, so now let's move on to the concept of software, or the computer program. So when I had previously asked you regarding the software, I've got an answer that uh, the programs that run on the hardware is called as the software. Yes. So now,
Yeah.
can you tell me the different types of software that you use?
Fortnite, Chrome,
Yes, your phone.
Zoom,
It might be at your school. It might be at any place that you go to play. So
Zoom.
Zoom. Oh, okay. Yes. So Zoom is a software that we use to conduct meetings, share our screens, and basically share our work. And what else? So tell me, what operating systems do you use?
iOS, and Windows.
Okay, iOS and Windows. Uh, Anybody else who uses any other operating system?
Mac OS.
Linux.
Okay, Linux. Yes, nice. So popularly, we use Windows, the Mac OS, and Linux. So talking about software, all we need to know about software is that software is a piece of program that runs on hardware, and something which can give us some output. Yes, so now we have seen uh, two examples of the software. One is Zoom, and the other is an operating system. Yes, so the reason why I have discussed the concept of an operating system and and an application like Zoom is that there's a basic difference in between these two types of software. One is called as the system software. The other is called as the application software. Okay, so which one do you think is a system software? Which one do you think is an application software?
Because you can use the chat function to answer.
Can you ask the question again?
So I have discussed that we have two types of software. One is the system software, the other is the application software. So the operating system, is it a system software or is it an application software? Like,
System software.
yes. So Windows, Linux, or your Mac OS are called as system softwares, and other the other example that we have received is Zoom, or it could be your VLC media player, it could be a game. So all these come under application software. So one thing that you need to remember is a system software is an operating system, and an application software is a program that needs system software in order for it to execute. Okay. So am I clear with this basic point of the difference between a system software and an application software? This is a basic thing that I would like all of you to know, because going forward in the course, we will be using both system software and application software in order to build our uh, applications. Okay, so we will be using Linux and and the Raspberry Pi to build programs using Python, application programs using Python. So let's have a checkpoint over here to know if you have got the concept of a system software and the application software. Are everybody okay?
I think Pranav asked a question about repeating system.
Yes. Yes, I see Madhav has raised a hand.
That was by accident.
Okay. Somebody else was asking a question. I'm
Yashwant.
sorry.
Yashwant had a question.
Yashwant, could you please repeat the question again, please? I think I lost.
Can you go over system software one last time?
Yes, sure. So, system software is nothing but your operating system, and you need a system software in order for your application software to run. So you cannot run the application software without a system software. So you need an operating system in order for you to run applications. Like for example, if you want to run your game, so can you play a game directly on the hardware? No, we cannot. We need to install an
No.
operating system first in order for you to play the game. So that is where your system software comes into picture. I hope I have cleared your query. Can I move on?
Yeah, go ahead.
Yeah, okay. Okay, so in order for a computer to function, a software is not an optional part, but it's an essential part. We need to have software on your computer in order for us to make it work. So we have discussed two components. The first component is our hardware. The second component happens to be the software. But we also have third hidden part, and that part is our internet. Okay, so can you uh, tell me why I had put the discussion on internet over here? Uh, can we run a computer without an internet, or is it necessary that we have an internet?
No, it isn't.
Okay.
The computer would still work, but you couldn't access some things that would be on the web.
Okay. So I have an answer that internet is not a necessary part, but uh, we tend to use the internet because we might require the internet. I'm sorry, I have a technical issue at my. Yes, I'm back. So we need not have internet, but we are including the internet part because computers these days, they require internet for doing various jobs, and we will also be using internet in our coming projects in order to connect our physical things with the internet. So internet, you can think it as a glue between your physical thing and your computer. Okay, so let me move on to the next concept of how computers store data. Okay, so where do you guys store your data?
On my SSD or my
Yes, on have an answer that you store it on your SSD or HDD. That is your hard disk, right? Okay, so
yeah.
anybody else? Where do you store your data apart from hard disk?
On like a flash driver, like a
Yes,
something like that.
yes, yes,
Like you can use a cloud.
yes, correct. So we can use multiple devices like the hard disk or a cloud or a flash drive in order for us to store our data. Now let's move on to our concept of how computers store data. We have seen that where we store our data in a computer, but now let's see how computers store data. Uh, do anyone over here know how uh, data is stored in a computer?
It uses binary.
Yes, correct. So we use binary in order, sorry, a computer uses binary in order for it to store data. Now, what is binary?
A computer language.
No, binary is not computer language.
Isn't there a set of ones and zeros that can be converted into messages?
Yes, close enough. So binary is nothing but representing a state of whether it is present or not. See, one maybe let's say let's consider an example of a switch. And what are the two states of a switch? It could be on
On or
or
off?
it could be off. So when I say binary, I represent something similar to the states of a switch. One, which means the switch is on. Zero means the switch is off. Now, what do we mean by switch being on and switch being off? See, when I suppose say I have a switch for say your refrigerator, and I have switched on the refrigerator. Now, what does that mean? It means that we have electricity passing on from the cables into my refrigerator, correct? So what does that mean? It means there is some flow of electricity that is happening, and uh, it means that whenever this switch is on, I have some electricity flowing inside my refrigerator. Now when I switch it off, I do not have electricity. So similarly, this concept is somehow analogous uh, with respect to your the storage uh, of data in our computers. So when we pass electricity, it means we have a on connection, and which means that the data is present at that point. And when it is off, it means that there's no electrical connection, and it physically means that we do not have data at that point. Do you all agree to this? see, presence
That
of
makes sense.
electricity. Yes. Go ahead, please.
You asked if we agree, and I said yeah.
Yes. Okay. So the presence of electricity, which means 1. The absence of electricity, which means a 0. So let us see how this concept of ones and zeros, or the concept of binary, is used to store uh, uh, data. So now let us consider um, representing a number in terms of binary mathematically, and then we will learn the concept of what a byte is, and then we will be learning more on a few other concepts of so that we understand the memory better. Okay, so let me just uh, set up one simple thing. I will be okay. So for the next 10 minutes, we will be dealing with a few concepts of math in order to understand the concept of bit and a byte better. I hope you're able to see the notepad that I have over here. So first, we use the concept called as bit and byte in order for us to represent data. Now, 1 byte is actually equal to 8 bits. Okay. So 1 byte is actually equal to 8 bits. Now, what is a bit? 1 or 0 is called as bits. Okay. So if it is either 1 or 0, then it is called as a bit. And a byte is collection of 8 such bits. Okay. So it could be 1 0 1 0 1 0 1. 8 such things collectively are called as uh, is called as 1 byte. Okay, let me just enter the screen. This is better. 1 2 3 4 5 6 7. Okay, so any number or any character is converted into a series of ones and zeros, and it is stored inside a computer. Let's take an example. Say a number 77. Now let us see how we can convert this number 77 into binary form. Okay, so you take 77 and you divide it by 2. Now what happens when I divide 77 by 2? What is the reminder that I get by dividing 77?
5 is going to be 38.5.
Yeah. 38 times is 76, and I have a reminder of 1. So I represent it this way. 2 into 38 is 76, and I put the reminder aside. Now I'll continue. I'll further divide it with 2. Now 19 times 2 is 38. 19 times 2 is 38, and the remainder I have is 0. Now I'll further divide it by 2. Say 9 times 2 is 18, and I have a remainder of 1. Similarly, again I further divide by 2 until I'm left with an answer of either 1 or 0. So 4 times 2 is 8, and I have a remainder of 1. Then moving on, 2 times 2 is 4, remainder is 0. 1 times 2 is 2, and the remainder is 0. Now let me just collect my ones and zeros and form a new number. Okay, so what do I get when I collect these ones and zeros? 1 0 0 double 1 0 1 1 0 0 double 1 0 1. Okay, so 77 is represented in binary as 1 0 0 double 1 0 1. Okay, so now what does this mean? Say I have my memory like this, and here I give an electrical connection in my first block. In the second block, I deny an electrical connection. In the third block as well, I deny an electrical connection. In the fourth and fifth block, I accept an electrical connection to it. In the sixth block, I again deny an electrical connection, and in my seventh block, I accept an electrical connection. So
So
I accept my
basically,
electrical connection.
when it's a 1, it's an exception, and when it's a 0, it's not an exception, right?
Yes. So when it is a 1, I have an electrical connectivity. When it is 0, I do not have an electrical connectivity. So this is how we actually represent numbers as binary, and then this in this way a computer storage understands that, hey, when I have this pattern, then the number is 77. Similarly, let us move on with a few other exercises so that you know or understand the concept of um binary representation better. Okay, so when we consider it as uh, the concept as switches, you can consider it as on off on off on off on off, like that. So whenever we have electrical connectivity, it's represented by 1. Whenever we do not have, we can represent it as a 0. So here we have a few other examples on how we can represent any number in a binary format. So here we have seen that a binary thing is represented by 0, 1, 0, 0, 1, 0, 1. If you can see our answer that we had got, let me put a 0 in front of this thing so that I form 8 bits. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. I have 8 bits and it is represented as 0, 1, 0, 0, 1, 0, 1. Similarly, yeah, see this over here. Off, on, off, on, off, on, which means 0, 1, 0, 0, 1, 1, 0, 1. This is our number 77 stored in a byte. Okay, so now we have seen on how we can store numbers in terms of bytes. So I have a small exercise for you guys. Let's see on how you can do it. Let's take, I'll do the first 2 things for you today, and the rest 2, I will leave it as your homework. So when we meet in our next class, I want the answer for 3 and 4, that is the numbers 266 and 1000. How we can represent the numbers 266 and 1000 in terms of binary. So let us begin with this exercise of the number 10. Okay, so yeah. Now I would like you guys to answer and help me solve this binary representation. What do I need to do? I need to divide 10 with 2. Okay, so how many times 2 is 10? How many times 2 is 10?
5 times.
Yes, 5 times 2 is 10. And what is the remainder?
0.
Yes, correct. Next, I keep on dividing it by 2 until I reach 1 or 0 at my last point. Okay, so now do I have a 1 or 0 over this place? No. So I have to continue my division. Now say, what is the closest number that I can have to 5, which is a multiple of 2?
4.
Yes. So when I want 4, I need to multiply 2 with 2. 2 2s are 4. And when I subtract 5 with 4, I have a remainder of
1.
1. Correct. So next, I go on dividing it by 2. So how many times 2 is 2?
1.
Yes, 1. And what's the remainder that I'll be left with?
0.
0.
0.
Yes. So at this position, I have got 1. So I'll be stopping my division. So I'll be so remember that whenever I get a 1 or 0 at this position, I'll have to stop my division. Now let me write my numbers in a reverse way. 1 0 1 0. So this is how I represent the number 10 in terms of binary. Okay, so I need 4 bits, 1 0 1 0, in order for me to represent a number 10 and store it in my memory, right? So now you can have a doubt that we already we only have 4 bits, but a byte consists of 8 bits. Byte is essentially 8 bits, right? So what about the rest 4 bits? We have got 4 bits over here. What about the rest? The rest are filled with zeros. Okay, so this forms 8 bits. So whatever the number uh, that that is on the left hand side of the most significant bit over here, I fill it with zeros. Okay, so in our byte we have the concept of MSB and then LSB. It is called as most significant bit and least significant bit. The first bit is called as the most significant bit, and the last bit is called as the least significant bit. Now, I will share you another example of the number 266. Now let us also try to solve this, and let's see on how we can represent the number 266 in terms of binary. Okay, so I take 2 and divide 266 by 2. How many times of 2 is 266? 133, right?
Yeah.
So,
133.
so what is the reminder? 133 times 2 is 266, and what's the reminder?
0.
0. So I represent my reminder over here, and then I further divide it by 2. Now I have a number called 133. 133, is it an even number or an odd number? It's an odd number, right? So are odd numbers divisible by 2?
No.
No. Yes. So what is the reminder that I will get when I divide an odd number by 2?
1.
Yes, 1. So let me just subtract that 1 from 133 over here, and I will get a number called as 132. And now I will have to evaluate how many times 2 is 132. Can anybody answer that?
66.
Yes. 66. Is that the answer?
Yeah.
Yes, correct. So 66 times 2 is 132, and I have a reminder 1. Okay, so 66 times 2 is 132, and 132 plus the reminder 1 gives me 133. Next, I'll have to further divide my number by 2. How many times 2 can give me 66?
33.
33, yes. And what would be the reminder?
0.
0, correct. Next, I'll be further dividing it by 2. Now, 16 times 2 is 32, and I'll have a reminder of 1. Next, 8 times 2 is 16, and I'll have a reminder 0. 4 times 2 is 8, and I'll have a reminder 0. 2 times 2 is 4, and I'll have a reminder 0. 2 times 1 is 2, and I'll have a reminder 0. So, and I'll have to collect all my numbers from backside uh, for me to form uh, to represent the number 266. So what is the number that I'll be having? It is 1 0. How many zeros I have? 4 zeros. 1 and 4 zeros followed by 1 0 1 0. Right. So how many bits that I have over here? 1 2 3 4 5 6 7 8 and 9. Now, how many bits do I have in a byte?
8.
Yes, I have 8 bits in a byte, but I have got 9 bits over here. So how do you think we can store a number called 266 inside a computer? It's simple. I use the concept of borrowing. So I can use 2 bytes. 1 byte will store these 8 bits, and the second byte will store this one along with 7 zeros. Okay, how many numbers have I put out here? 1 2 3 4 5 6 7. Yeah, 7 zeros and 1 1 will be in 1 byte. The rest of the numbers will be in another byte. So we see that we can use 2 bytes in order to store a number, a larger number like 266. Okay, so this is how we represent the numbers in binary, and this is how it gets stored in a computer. I want you people to perform the exercise on 100 and 1000, and let me know the answers on how we can represent 100 and 1000 in terms of binary. So now we have seen on how we can represent numbers in binary and use this to store in a computer. But what about characters? Say, I have different characters, my alphabets, capital A, small a. Then I have special symbols like @ that you use in an email. Okay, so if it is a number, then it's straightforward. What I do is I keep on dividing it by 2, and I will collect all the reminders. I'll keep on dividing it by 2, and I'll collect all the reminders in order for me to store it in a byte. Right. So, but what about characters like this? What about characters? Do anybody know? Or can you use your intellectual ability of a 13-year-old and suggest something new on how I can represent a character like A?
They could do like A1.
Mm-hmm.
And like B2, C3, D4.
Oh, okay. A, uh, uh, A1, B2, C3. So A, I can substitute it with a number, and I have an answer that I substituted with a number called 1, and B, I substituted with 2, C with 3. So this is how exactly in the same way that characters are stored uh, in memory, but it's not with 1, 2, and 3. It's with another number called 65, 66, 67, and so on and so forth. Similarly, capital A is represented by another number called 97, capital B by 98, and so on and so forth. Similarly, even my special characters like at the rate, exclamatory mark, full stop, comma, etc., each have their own number representation for us, for the computer to understand it as that character. So what computer does is whenever it retrieves such kind of numbers, we perform some kind of encoding to it, and we know that when we decode that particular thing, we know that it's the character that is stored over here. Okay, so each of these characters require 1 byte, 1 byte per character. Okay, so each of these characters require 1 byte, uh, and let me have 5 more minutes of your attention so that I will complete this session. So 1 byte is used to represent one character. That means 8 bits are required per character, and the reason behind this is the largest number that you can fill with 8 ones is 127. So the largest number that I can fill with 8 ones is actually 127. See, let me just divide by 127 by 2. What do I get? I get a reminder 1. And how many times 126 is 2? You can evaluate this thing. You will get reminders as uh, 8 ones over here. So that is how we know that we can store the largest number using 8 ones is 127. And what are my characters over here? All of them are less than 127. So I can establish by fact that the largest number that I can store, since it is 127, I will require less than 8 bits or 8 bits for me to represent characters. So that's how I established this concept of 1 byte per character. Yes, so I hope you have got this concept of what a byte is, what a bit is, and how we represent numbers and alphabets and store them in your computers. So I will end my lecture on Introduction to Computers and Programming with this concept. From our next lecture onwards, we will go forward with the installation of Python IDE and start our basics of programming. And this introductory session was intended for you to learn how we store numbers and characters or stuff in a computer, so that you will know uh, 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 when you know these concepts, programming will be easier for you. So I am ending my lecture over here. Uh, anybody else has any doubts on what we discussed today?
No, everything makes sense. Thank you for your time.
Is it hard?
No, it's fairly simple.
Okay. So practice the numbers 100 and 1000 and share me the answers. I will shortly share you whatever that I have written over here on on Google or on WhatsApp, so that you can refer it and use it to solve your problems. From our next class onwards, we will be discussing the concept of using Python and what a programming language is and how you can use the programming language uh, for you to write code so that you run a program, and then we will use the concepts of Python in order for us to execute IoT projects. Okay, thank you all.
Thank you. Thank you, guys. We'll meet up on Saturday, same time. Thank you, guys.
Okay.
Thank you for your time.
Yeah, bye-bye.
Yeah, bye.